Good morning, and once again, welcome to my YouTube channel, Pearson Edexcel International Maths. We've just introduced ourselves to partial fractions, which is pure mathematics 4, and example 2, which is on page 8. And we are being told that the method of partial fractions can also be used when there are more than two distinct linear factors in the denominator. And for example, if you have 7 all over x minus 2, x plus 6, and then x plus 3, you can always write it in form of a over the first divisor, x minus 2, plus b over the second divisor, x plus 6, plus c over the third divisor, which is x plus 3, not b, x plus 3. And where a, b, and c are constants to be found, you can either use substitution or comparing coefficients approach to get the values of a, b, and c. And I want us to directly go to example 2, which says that given that 6x squared plus 5x minus a 2 all over x minus 1 and 2x plus 1 is equals to, or can be written as, a over x is the first divisor, plus b over the second divisor, and plus c over the third divisor, 2x plus 1. Find the values of the constants a, b, and c. The question is find a, b, and c. That is the question. And fine, we would wish to let all of us understand that anytime we have this kind of an expression, we kind of bring the denominator or the LCM of the denominator on board. And how do we go about this? The LCM is x minus 1, 2x plus 1. Incidentally, when you divide by the first divisor, you get the other two. When you divide by the first divisor, you obviously get the other two. So when you multiply by that numerator, so for instance, in the first one, you're going to have a multiplied by, because the denominator of a is x, so the whole of this divided by x, you get the other two. So the other two multiplied by a, you get x minus 1, 2x plus 1, plus b. Of course, now b, the divisor, the denominator of b is x minus 1, so you get the other two. So bx multiplied by 2x plus 1. And of course, when you get to c plus c, the denominator of c is this, so you get the other two, x minus 1. And that is just like it. And this is now written in form of, it's compared to be equals to 6x squared plus 5x minus 2 all over x minus 1, 2x plus 1. That is just like it. And at that particular point, we wish now to talk of how we can easily keep nullifying some of these brackets so that they are 0. So for example, if we take x to be equals to 1, if we take x to be equals to 1, you'll see that the whole of this bracket will be 0 and the whole of this bracket will be 0. So we say let x be equals to 1. So what is here? This is 6 plus 5, 11 minus 2. That the whole of that side gives us 9. And if you look at x being 1 now across, 1 minus 1 is 0, so the whole of that is 0. And 1 minus 1 is 0, so the whole of that is 0. But 1 times 2 is 2. 2 plus 1 is 3. 3 times b, because there is b1 here, it's 3b. And at that point, b should be equals to 3. Our b is equals to 3. We have made x to be equals to 1 to nullify this bracket. But there is this x, so let x be equals to 0, such that when x is equals to 0, the whole of this term will be 0, and the whole of this term will be 0, because x is just multiplied directly with a constant. And what we have here is 0 plus 0 minus 2 is equals to, that is 0, this is 0. So there is 0 minus 1 here, which remains minus 1. And there is 0 plus 1, which remains plus 1. So minus 1 times plus 1 is minus 1. Minus 1 a is minus a. So easily we can see that our a is equals to 2. At that point, the bracket we have no 0, this bracket, we are going to let x be equals to, what can we have to make this equal, x equals to, so that the whole of this bracket is 0? It's easily negative a half, such that 2 times negative a half is negative a 1, and negative 1 plus 1 is, so the whole bracket is 0. The whole of this term is 0, so we are left with probably this term. And when x is negative a half, so it goes without saying that negative a half squared, let's just substitute here, 6 negative a half squared plus 5 negative a half minus 2. It becomes what? That is going to be 0. This is going to be 0. C times negative a half is going to be C negative a half, and then negative a half minus 1. What is negative a half minus 1? Of course, negative 1 and a half. Negative 1 and a half times minus a half. We are going to find out what that is. Incidentally, we are going to evaluate the whole of this and have 6 over 4 minus 5 over 2. You see, 6 divided by, or rather 6 divided by, because this is what we are having, minus 5 over 2, and of course minus 2, we get a negative 3. So the whole of this side gives us a negative 3 is equals to minus 1 minus a half is minus 3 over 2. Minus 3 over 2 times minus a half. Minus 3 over 2 times minus 1 over 2. What are we having? We are going to get 3 over 4. We're going to get 3 over 4c, because this c continues to exist. So at the end of the day, we are going to have minus 12 is equals to 3c, and it goes without saying that c is equals to minus 4. C is equals to minus 4. So you can see that we have used substitution method, and you can also as well use comparing coefficients method. That means you open these brackets and compare what we have, x squared. I think I'll do this in a different video, but for now we are going to talk about 6x squared plus 5x minus 2 all over x x minus 1, 2x plus 1 to be exactly equals to a, what is our a? 2 over x. What is our b? What is our b? Plus 3 over x minus 1. What is our c? Minus 4 all over 2x plus 1. And that is just what we have had, and it's as simple as that. All right.